In this video, we're going to go over the KutaSoftware Infinite Calculus free worksheet, average rates of change. Now, quickly, I want to note that the average rate of change is the slope of a secant line. And remember, a secant line is a line that intersects a curve at 2 points. So finding the slope of that secant line is finding the average rate of change over the interval of those 2 points. So for numbers 1 and 2, it says find the average rate of change of the function over the given interval. In number 1, we have x squared minus x plus 1 over the interval from 0 to 3. Now I'm going to write a quick formula to help us find the slope of that secant. So the slope of the secant is equal to the function evaluated at the end interval minus the function evaluated at the start of that interval all over the value of the change in the interval. So our starting interval value is at 0 and our end is at 3. So we're going to find f of x, so the y value or the function value when x is equal to 3. Then we're going to find f of a, the function value or y value when we are at 0, and that's going to be subtracted. And then we're going to take 3 minus 0, essentially the change in x. So remember, slope is change in y over change in x. Here we're finding the change in our function value over the change in our x values. Delta y over delta x. Our interval starts at 0, and when we're at 0 in the x, we're at 1 in the y, and then the end of our interval is at 3 in the x, and that's equal to 7 in the y. So you can see our secant line is the line from the start of our interval to the end of our interval and where that intersects our function. And remember, slope is rise over run. So I can calculate this slope just from looking at my secant line. You can see that rise, as we go up 2, we go over 1 in the run. So that's 2 over 1. Again, up 2 over 1 in the run, up 2 over 1 in the run. So our slope is equal to 2. But let's double check that using our formula. So I'm going to have f of x, which will be f of 3, minus f of a, which will be f of 0, all over x minus a, 3 minus 0. F of 3 is going to be 3 squared minus 3 plus 1. F of 0 is going to be 0 squared minus 0 plus 1, and that's all over 3 minus 0, which is 3. So our change in x, you can see, is 3. 1, 2, 3. Now let's find that change in y, or change in f of x. 3 squared is going to be 9, so we'll have 9 minus 3 plus 1 minus 0 squared, which is 0, minus 0 is 0, and we're just subtracting that positive 1. And that's all over 3. 1 minus 1 is 0. 9 minus 3 is 6, so I'll have 6 over 3. So you can see that that change in y, our change from f of x to f of a, is 6. So the change in y, 1, 2, 3, 4, 5, 6. 6 over 3 is equal to 2. Change in y over x will give us our slope for our secant line of 2. Let's continue on to number 2. In number 2, we're finding the slope of our secant line from the interval -3 to -2. So our a, our start value, is -3, and our end value is -2 for our interval. So when we're at -3 in the x, we're approximately here on our graph, and then at -2, we're approximately here. So you can see that secant line has a relatively small change as compared with number 1. And because we cannot see those values, we cannot attempt to calculate it without entering our values in. So remember, f of x minus f of a over x minus a will give us the change in y over the change in x. So f of x will be f of negative 2, and I'll be subtracting f of a, which is f of negative 3, and that's all over x minus a, which is negative 2, minus a negative 3, or negative 2 plus 3. From there, f of negative 2, plugging negative 2 into our equation for y, we'll have negative 1 over negative 2 minus 2, and then we're going to be subtracting f of negative 3, which is a negative 1 over negative 3 minus 2, but as opposed to subtracting a negative, I'll add the positive 1 over negative 3 minus 2, and that's all over negative 2 plus 3, which is a positive 1. So you can see that our change in x values was a positive 1. For change in y, it's a lot smaller. Simplifying, we have negative 1 over negative 2 minus 2 is a negative 4, and a negative over a negative is a positive. So I'll have positive 1/4 plus 1 over negative 3 minus 2 is 1 over negative 5, which is negative 1/5. And again, that's still all over 1 for our slope. Putting these in like terms, 4 and 5 have a common denominator, or a least common multiple, of 20. So to get from 4 to 20, we're multiplying by 5. So 1/4 we will write as 5/20. And to get from 5 to 20, we multiply by 4. So we're going to multiply negative 1/5 by 4 over 4, which will be negative 4 over 20. And that's all over 1. So you can see that our change in y, 5 plus negative 4, is a positive 1 over 20. And that is all over 1. So our change in y from that point to that point was 1/20. And 1/20 divided by 1 is 1/20. So our slope is also 1/20. Now let's move on to numbers 3 and 4. For numbers 3 and 4, it says for each problem, find the equation of the secant line that intersects the given points of the function. And in order to find the equation of the secant line, we need to use that slope and then plug it in to point slope form by using our given points. So let's look at number 3 and go through those steps together. And number 3, we have y equals negative x squared plus x plus 2. We're going from the point negative 2, negative 4, so plotting that, negative 2, negative 4, to the point 1, 2. So we're finding the equation for this secant line. So you can see our interval is our x values, so from a to x. So we're finding the equation of the line a, f of a, and x, f of x. So f of a and f of x are already given to us, because if we were to plug a of negative 2 in for x, that results in a negative 4, and you can see that because that point falls on the function, negative 2, negative 4. And plugging 1 in for x, we'll get negative 1 plus 1, which is 0, plus 2, which is 1, 2, which was already given to us. So because a, f of a, x, f of x are given to us, it's easy to plug that into the formula. So remember, we have the formula for the slope of the secant line. It's the change in y over the change in x. So the change of our function evaluated at the given intervals over the change in that interval. So the slope of the secant in secant is f of x minus f of a, which is 2 minus negative 4. So we have 2 minus negative 4, and that's all over x minus a, 1 minus negative 2. 2 minus negative 4 is 2 plus 4, which is 6, and 1 minus negative 2 is 1 plus 2, which is 3, and 6 over 3 is a positive 2. So the slope of our secant line is 2. Now we're going to take that value for our slope and use it in our point slope form. Remember from algebra, point slope form is y minus y1 equals m times x minus x1. That's how we find an equation of a line. And we're already given x1 and y1. Actually, we're given two different values. We can use -2, -4, or we can use 1, 2 as x1 and y1. Let's go ahead and use 1, 2. So I'll have y minus y1, which is 2, equal to our slope of 2, because we calculated the slope of the secant to be 2, and that's multiplied by x minus x1, which x1, using the point 1, 2, as x1, y1 is 1. So what I'm going to do is distribute my 2. So I'll have y minus 2 equal to 2x minus 2, and then I'll add 2 to both sides to isolate my y so that I'm in the slope of y equals mx plus b. So that's going to be y equal to 2x, and -2 plus 2 is 0. So y equals 2x is the equation for my secant line that intersect my function at the points -2, -4, and 1, 2. Let's continue on to number 4. And number 4, my secant line, I'm evaluating that when it intersects the function at 1, -1 to 3, -1/3. So I'm finding the equation for the line I just drew. And our interval starts at 1 and ends at 3. So we'll have a as 1, x as 3. So that means that f of a is -1 and f of x is -1/3. And again, that's because these points fall on the equation. So when we're at 1 for a, we're at -1 for f of a. 3 for x, we're at -1/3 in f of x. So for the slope of our secant line, we have f of x minus f of a, which is -1/3 minus a -1, and that's going to be all over x minus a, the change in x, 3 minus 1. Change in y, change in my function values evaluated at the interval, over the change in x, the change in my interval. So that's going to be equal to, I'm going to write my numerator so that I can simplify by adding. So I'll have -1/3 plus, because if I'm subtracting a negative, it's the same as adding a positive, but I want to put 1 in terms of 3, so that's going to be 3 over 3. So -1/3 plus 1, or plus 3 over 3, all over 3 minus 1, which is 2. So you can see that my change in x was 2, so delta x is equal to 2. Now I'm just solving for my change in y. -1/3 plus 3/3 is going to be a positive 2/3. So that's 2/3 over 2. So my change in y was 2/3. And my change in y over my change in x is 2/3 divided by 2, which I'm going to write as 2/3 times the reciprocal of 2, which is 1 over 2, which will give me 2 over 3 times 2, which is 6, which simplifies down to 1/3. So the slope of my secant line is 1/3. Now I'm going to use point slope form to solve for the equation of my secant line. So y minus y1 equals m times x minus x1, which I'll use 1 and -1 as x1 and y1. So y minus a -1 equals our slope m, which we calculated to be 1/3, times x minus x1, which is 1. Minus -1 I'm going to write as plus 1, and I'm going to distribute that 1/3 to the x and to the 1. So I'll have 1/3 x minus 1/3. Next, I'm going to be subtracting 1 from both sides, so I'll have y equal to 1/3 x minus 1/3 minus 1. But as opposed to writing that as subtracting 1, I'm going to write that as subtracting 3 over 3 so that I can combine 1/3 with 1. So that's going to be y equal to 1/3 x minus 1 minus 3, but negative 1 minus 3 will be a negative 4, so I'm going to be subtracting 4/3. So the equation for my secant line in number 4 is y equals 1/3 x minus 4/3. So let's continue on to the second page. Now, in the second page, I'm finding the average rate of change of the function over the given interval. So remember, average rate of change is the slope of that secant line. So I'm just solving for the slope. And remember, that's f of x minus f of a all over x minus a. So number 5, my a is negative 2, my x is negative 3 halves. So I'll figure out what f of negative 3 halves is, f of x. That's going to be negative 3 halves squared plus 2, which negative 3 halves squared is negative 3 squared over 2 squared, which is 9/4. And adding that to 2, I'm going to add that to 2 in terms of 4. So that's going to be 8 over 4. And 9 plus 8 will give me 17. So I'll have 17/4 as f of x. Next, I'll solve for f of a, which is f of negative 2. So I'll have negative 2 squared plus 2, which equals 4 plus 2, which is 6. So f of a is 6. Now I can write this in my formula. F of x minus f of a over x minus a. That's going to be 17/4 minus 6 all over x of negative 3 halves minus a of negative 2 minus negative 2 I'll write as plus a positive 2. So writing 6 in terms of 4, I'm going to have 17/4 minus 24/4, and that's all over negative 3 halves plus, writing 2 in terms of halves, 4 halves. Simplifying further, 17 minus 24 is a negative 7, so I'll have negative 7/4 divided by negative 3 halves plus 4 halves is going to be a positive 1/2. So I have negative 7/4 over 1/2, which I'll write as negative 7/4 times 2 over 1, because dividing by a fraction is the same as multiplying by the reciprocal. Negative 7 times 2 is a negative 14, and we'll have negative 14 over 4, but each of those can be simplified by dividing by 2. Negative 14 divided by 2 is negative 7, and 4 divided by 2 is a positive 2. So I have negative 7 halves as the slope of my secant line in number 5. In number 6, a is negative 1, x is negative 1/2. So I can calculate f of x, calculate f of a, and then write that all over x minus a, or we'll just do one long equation plugging in everything as we go. So f of x is going to be 2 times negative 1/2 squared minus 2 times negative 1/2 plus 1. So that is f of x, and I'm going to be subtracting f of a, which is 2 times negative 1 squared minus 2 times negative 1 plus 1, and that's all over x minus a, negative 1/2 minus a negative 1, which I'll write as negative 1/2 plus a positive 1. So let's simplify. Negative 1/2 squared is going to be a positive 1/4, so I'll have 2 times 1/4 minus negative 2 minus 2 times negative 1/2 is going to be a negative 1, but if I'm subtracting a negative, that's the same as adding a positive. So that'll be plus 1, and then I'm adding 1 again, and then I'm subtracting the quantity 2 times negative 1 squared, which negative 1 squared is a positive 1, and 1 times 2 is 2, and then I'm subtracting 2 times negative 1, which will be adding a positive 2, and then I'm adding that to 1. And that's all over negative 1/2 plus 1, which is a positive 1/2. So continuing my work, 2 times 1/4 is 1/2. So I'll have 1/2 plus 1 plus 1 is 2. But then I'm subtracting 2 plus 2 plus 1, which is 5. And that's all over 1/2. Simplifying further, I'll have 1/2 plus 2 minus 5 is a negative 3. And that's all over 1/2. Writing negative 3 in terms of halves, I'll have 1/2 plus negative 6/2 all over 1/2. 1/2 minus 6/2 is going to be negative 5/2. And I'm dividing all that by 1/2, which I'll write as negative 5/2 times 2 over 1, because dividing by a half is the same as multiplying by 2. And you can see that my 2's will cancel out, because the 2 in the numerator will cancel out with 2 in the denominator to leave me with negative 5 over 1, which is negative 5. So negative 5 is the slope of my secant line in number 6. In number 7, I'll calculate f of x, and I'll calculate out f of a. A is negative 1, x is negative 1/2. If we do f of a, we have f of negative 1, and f of x will be f evaluated at negative 1/2. So plugging in negative 1 for x, we'll have negative 1 over negative 1 plus 2. That's going to equal negative 1 over negative 1 plus 2 is a positive 1, so that's equivalent to negative 1. So f of negative 1 is negative 1. Now, for negative 1/2, we have negative 1 over, plugging negative 1/2 in for x, that'll be negative 1/2 plus 2. So we'll have negative 1 over negative 1/2 plus 2 is going to be a positive 3/2. Because if I was to write 2 in terms of halves, that'd be 4/2, and negative 1/2 plus 4/2 is 3/2. So if I have negative 1 over 3/2, I can simply flip this denominator. Or you can think of it as multiplying by the reciprocal. So multiplying negative 1 by 2 over 3 will give me negative 2/3. Now that I have f of a and I have f of x, I can go ahead and plug that into my slope formula for the slope of the secant. That gives me that average rate of change over this interval. So f of x minus f of a all over x minus a. That is negative 2/3 minus a negative 1 all over x, which is negative 1/2, minus a, which is negative 1. So negative 2/3 minus a negative 1 is negative 2/3 plus 1, which is a positive 1/3, and that's all over negative 1/2 minus a negative 1, which is negative 1/2 plus 1, which is a positive 1/2. So if I have 1/3 divided by 1/2, I can write that as 1/3 times the reciprocal of 1/2, 2 over 1, to give me 2/3 as the slope of my secant line. So 2/3 is my solution in number 7. And lastly in this section, number 8. A is 0 and x is 1/2. So f of x is going to be 2 times 1/2 squared plus 1/2 plus 2. And I'm going to be subtracting f of a, which is 2 times 0 squared plus 0 plus 2. So here we have f of x, and here we have f of a. And I'm subtracting those. So f of x minus f of a, that's the change in y, all over the change in x, which is 1/2 minus 0. So simplifying, 2 times 1/2 squared is going to be 2 times 1/4, which 2 over 4 is equal to 1/2. And I'm going to be adding that to 1/2, and then adding that to 2, and then subtracting 2 times 0 squared is 0, plus 0 is 0, and then I'm adding 2. But remember, I'm subtracting this entire quantity. So in the end, I'm going to be subtracting 2. And that's all over 1/2 minus 0, which is 1/2. 1/2 plus 1/2 is 2/2, which is 1. And then 2 minus 2 is 0. So I'll have 1 over 1/2, which dividing 1 by 1/2 is equal to 1 times 2 over 1, which equals 2. So my slope of my secant line in number 8 is a positive 2. Now on to the next section. For each problem, we're finding the equation of the secant line that intersects the given points on the function. And remember, in order to find the equation for the secant line, we find the slope and then use point-slope form to solve. So in number 9, we have a, f of a, as 1, negative 3, and x, f of x, as 3/2 and negative 17/4. So f of x minus f of a is going to be negative 17/4 minus a negative 3, but subtracting a negative 3 is the same as adding a positive 3, and that's all over x minus a, 3/2 minus 1. So negative 17/4 plus 3, I'm going to write as negative 17/4 plus 12/4, because 12/4 is equivalent to 3. And that's all over 3/2 minus 1, which is a positive 1/2. Negative 17 plus 12 is going to leave us with a negative 5. So I'll have negative 5/4 all over 1/2. So my slope is going to be negative 5/4 divided by 1/2, or times 2 over 1, which equals negative 10/4. And simplifying that, I can divide both the numerator and denominator to get negative 5/2. So my slope is negative 5/2. Now I'm going to use point-slope form to solve. And remember, point-slope form is y minus y1 equals m times x minus x1. So y minus y1 I'll use as negative 3. So y minus negative 3 is y plus 3, and that's going to be equal to our slope of negative 5/2 times x minus x1, which x1 is the x coordinate that goes with the y value, which is 1. So now I'll distribute my negative 5/2. So I'll have y plus 3 equal to negative 5/2 x minus a negative 5/2 or plus a positive 5/2. And now I'll subtract 3 from both sides to get that y equals negative 5/2 x plus 5/2 minus 3 is the same as 5/2 minus 6/2, which will be a negative 1/2. So that's going to be minus 1/2. And if you need to see this fraction worked out quickly, 5/2 minus 6/2 equals negative 1/2. So my solution in number 9 for my secant line is y equals negative 5/2 x minus 1/2. Now on to number 10. I have a, f of a, and x, f of x. So for the slope, f of x minus f of a is 2/5 minus 1/2 all over x minus a, which is negative 1/2 minus 1, or plus 1. 2/5 minus 1/2, I'm going to write these with a common denominator in my numerator. So 2/5, I'll multiply that by 2 over 2 to get 4/10, and I'll be subtracting 1/2, which in terms of tenths, multiplying by 5 over 5, that'll be 5/10. And that's all over negative 1/2 plus 1, which is a positive 1/2. 4 minus 5 is negative 1, so I'll have negative 1/10 all over 1/2, which for my slope, I'll write as negative 1/10 times 2 over 1, which equals a negative 2/10. simplified is negative 1/5. So my slope is negative 1/5. Now I just need to plug that in to point slope form. So I'll have y minus y1, which I'll have x1 and y1 be negative 1 and 1/2. So my a, f of a. So y minus y1 will be y minus 1/2, and that's going to equal our slope of negative 1/5 times x minus x1, which is x minus negative 1, or x plus 1. So in order to solve, I'm going to need to distribute this negative 1/5. So y minus 1/2 equals negative 1/5 x plus negative 1/5, or minus 1/5. Now, adding 1/2 to both sides, I'll be able to isolate my y to get that y equals negative 1/5 x plus negative 1/5 plus 1/2. So writing that in terms of 10 again, negative 1/5 is going to be negative 2/10, and positive 1/2 is going to be positive 5/10. So y will equal negative 1/5 x plus negative 2 plus 5 is a positive 3, so 3/10. The equation of my secant line in number 10 is y equals negative 1/5 x plus 3/10. In number 11, we can see a f of a and x f of x. So for our slope, f of x minus f of a is negative 2/5 minus a negative 1/3, which I'll add a positive 1/3, and that's all over x minus a, negative 3/2 minus a negative 2, or plus a positive 2. Simplifying, negative 2/5 plus 1/3, I'll write in terms of 15 in the denominator. So multiplying negative 2/5 by 3 over 3, I'll get negative 6 over 15, and I'll be adding that to 1/3 times 5 over 5, which is 5/15. So you can see that my numerator is going to be a negative 1/15. Now in my denominator, negative 3/2 plus 2, I'll write as negative 3/2 plus 4/2, because 4 divided by 2 is 2. Negative 3 plus 4 is a positive 1, so that's 1/2. So I'll have negative 1/15 times 2 over 1 to give me negative 2/15 as my slope. Now, for slope-intercept form, I'll have a f of a be x1, y1. So y minus y1 will be y plus 1/3, and that's going to equal our slope of negative 2/15 times x minus x1, which is x minus negative 2, or x plus 2. Distributing that negative 2/15, I'll have y plus 1/3 equal to negative 2/15 x plus negative 2/15 times 2 is negative 4/15. Now I'll subtract 1/3 from both sides in order to isolate my y. So I'll have y equal to negative 2/15 x plus negative 4/15 minus 1/3, which in terms of 15, 1/3 will get multiplied to 5 over 5, which will be, so that's going to be subtracting 5 over 15. So I'll have y equal to negative 2/15 x minus negative 4 minus 5 is a negative 9, but as opposed to adding a negative, I'll subtract the positive 9/15. But quickly, 9/15 can be simplified down. So I'll have y equals negative 2/15 x minus 3/5, because 9 divided by 3 is 3, and 15 divided by 3 is 5. And that's my solution in number 11. And lastly, for this section, number 12. 1, negative 1 is a f of a and 3/2 negative 2/3 is x, f of x. And remember, a is the start of that interval, and x is the end of that interval. So I'm finding the secant line over that interval. So the slope is going to be equal to f of x minus f of a, which is negative 2/3 minus a negative 1, or plus 1, all over x minus a, 3/2 minus 1. Negative 2/3 plus 1 is going to be a positive 1/3, and 3/2 minus 1 is going to be a positive 1/2. So when calculating a slope, I'll have 1/3 times 2 over 1, which equals 2/3. So my slope is 2/3. Now it's time for point slope form. And for x1, y1, again, I'll use a, f of a. x1 for a, f of a is y1. x1, y1, a, f of a. So y minus y1 is y minus negative 1, which is y plus 1, and that equals our slope of 2/3 times x minus x1, which is x minus 1. Distributing that 2/3, I'll get y plus 1 equals 2/3 x minus 2/3. Then I'll subtract 1 from both sides to get that y equals 2/3 x, and then negative 2/3 minus 1 is going to be negative 5/3, but as opposed to adding a negative, I'll subtract a positive 5/3. And that is my solution and number 12. The equation of the secant line that intersects those given points is y equals 2/3 x minus 5/3. Now onto our critical thinking question, the last question on this worksheet. It says that the police have accused a driver of breaking the speed limit of 60 miles per hour. As proof, they provide two photographs. One photo shows the driver's car passing a toll booth at exactly 6 p.m. The second photo shows the driver's car passing another toll booth. This is 31 miles away, 31 miles down the highway at exactly 6:30 p.m. Does this photo evidence prove that the driver broke the speed limit during the time? Well, let's figure this out. Our interval is from 6 p.m. to 6:30 p.m. And I want this in terms of hours because we're looking at this in miles per hour. So the start of our interval is 0, and the end of our interval, 6:30, that's half an hour later. So from 0 to 1/2, 6 to 6:30, just in terms of hours. Where 6 is 0, half an hour later is 6:30. So this is the interval. Now we're going to calculate the change in miles. Now the change in miles is 31. So that is our change from f of a to f of x is 31 miles. Because at f of x, at time 0, we're at 0 miles, and when the time is equal to half of that hour, we reach 31 miles. So we're going to find the average rate of change, or the slope, to see if that surpasses the 60 miles per hour. And if it does, we know he is speeding. So f of x minus f of a is 31 miles, and that's all over the change in time. Starting from a going to x, we'll have x minus a in the denominator, which is 1/2, minus 0, which equals 1/2. So that's going to be 31 miles over half of an hour, which I can write as 31 times 2 over 1, which 31 times 2 is 62. So we'll have 62 miles per hour. That was the average rate of change. And the average rate of change is greater than that speed limit. Therefore, the photo evidence does prove that the driver broke the speed limit during this time. So again, my answer is yes. So yes, the average rate of change is 62 miles per hour, so the driver must have been breaking the speed limit some of the time. So again, he isn't necessarily speeding that entire time, but for the average rate of change to exceed that speed limit, he must have been going above 60 some of the time. And with that, we wrap up this calculus worksheet on average rates of change. If you found this helpful, don't forget to like the video, share the video, and subscribe to my channel. If you want more ways to show your support, pledge and become a patron. Go to maymap.com to find out more information or click the Patreon link below.